Hi everybody. So, because a few of you asked, I've put together a quick worked problem of the Solow growth model. Important to note that a more full discussion of the Solow growth model can be found in your book, or in one of the two author videos I've posted to Launchpad, or in the interactive tutorials. That's actually where I got this graph and question. I'm going a little bit further than they did in solving it, but you can find the same discussion or similar discussion there. So on the left we've got all the information we need, assuming that the savings rate is 30% and the depreciation rate is 1.5%, and of course assuming that our growth model is the standard one we've been using, y equals square root of k, which of course is shown over on the right on that graph. Then we can solve for the steady state equilibrium, or the equilibrium at which this economy will come to rest given how much people are saving and how quickly things are wearing out. Alright, so what do we know? We know that the depreciation rate is 0.015. We know that investment given by savings is a little bit of a tail there, 0.3. So now all that's left to do is to plug and chug. We know that the steady state is defined as a spot where the economy is neither growing nor shrinking. You can think of the steady state over here as where the depreciation is just catching up with investment, or investment's just catching up with depreciation. The same number of machines are being created that are wearing out the same rate. So if you had a graph like this, you could just eyeball it. But if we didn't have that graph, how would we solve for the steady state here? You'll notice that we are being asked for the steady state levels of both capital stock and output. I'm going to go for output first. So I'm going to be looking for y. What is that steady state of y? What's the value of y when we're at the steady state, where depreciation is just crossing investment? And it's worth restating this. So we've got y equals square root of k, which is the same as, we square both sides, y squared equals k. So now we have all the different forms of y and k that can be substituted into each other. And the general idea is that we want to set the function depreciation next to the equal to the function investment. So depreciation is 0.015 k is equal to investment, right where they cross each other, at 0.3 square root of k. And the levels at which this is true, the levels of k and the resulting level of y, where that's true, will give us the steady state equilibrium. Now you'll notice that we could solve for k, which is a little bit messier, or we could substitute what we know y and k are for each other. So let's do that. It's a little bit less messy, but either way works. So I'm going to restate this as 0.015. K is over here, y squared. So 0.015 times y squared. So now I've just restated this part. Now what's on the right? 0.3 square root of k. I know that is y. So now I need to solve for this. And that's a little bit easier to solve for. So I think first I'll divide both sides by y to get rid of that y. Divide that side by y, so now I've got 0.015 y squared over y, turns that into just y, equals 0.3. Now I can divide both sides by 0.15 to get it off of that side, and voila, I have 20. I've solved for y equals 20, right? So my y is still there, and it equals 20. And lo and behold, if you go up to the steady state, if we had this graph here, you'll notice where this crosses, where depreciation and investment cross, where we're at steady state, you're at a y of 20. And we're almost done. We are also asked for the steady state level of capital stock. So what's the level of capital stock when y is at 20? Well, we can see, we could just look at the graph and know that it's 400, but let's plug it in. We know, back to this part of the equation, y equals square root of k. And so if y is 20, 20 would be the square root of k. Square both sides, and you get k equals 400. So those are our answers. Y equals 20, k equals 400. And if you want to test yourself, make sure you can do it. I've changed the numbers here. The savings rate is now rising to 35%, and the depreciation level remains the same. So go ahead and solve it, knowing that you can use the same formula that I just used. And even without solving for it, we know probably what's going to happen as the economy begins to save more. You'd expect more available for capital investment. You'd expect that capital stock would rise. This will now be changed. The whole thing shifts up a little bit, and there's going to be where the depreciation investment cross is going to be at a slightly different level. So follow that up. We're going to have a higher level of steady state output. And you have y equals 23.3. And capital will be something above 400. Looks like capital will be somewhere in the neighborhood of 542. I hope that was fun. But if it wasn't, here's a little treat. How cool is that pointer? All right, see you in class.